suddenly somebody from the engineering team, steps up and says, but wait a second, you're telling us that if we want to automate this process, we can only pick one bill of material to go into the system. And I said, yes, that's right. Well, which one are we using? And the question just completely took me by surprise.
Growing a business requires a holistic approach that extends beyond sales and marketing. This approach needs alignment among people, processes, and technologies. So if you're a business owner, operations, or finance leader looking to learn growth strategies from your peers and competitors, you're tuned into the right podcast. Welcome to the WBS Podcast, where scalable growth using business systems is our number one priority. Now, here is your host, Sam Gupta.
Hey everyone, welcome back to another episode of the WBS Podcast. I'm Sam Gupta, your host and principal consultant at digital transformation consulting firm Elevate IQ. The automotive industry is unique, as not only it has challenges associated with B2C, such as focus groups and consumers driving the demand, but it also has all the challenges that other B2B manufacturing companies would have. The automotive industry is also fairly unique with faster cycle and lead times, which drives the need for instant availability of parts in the JIT fashion and reduces the BOM complexities. But since you have so many stakeholders and vendors involved in supplying parts, even a minor change in product assembly could impact the whole ecosystem, including OEMs and suppliers. In today's episode, we have our guest, Melissa Drew, who discusses the product life cycle of automotive products and how it is different from other industries. She also discusses the difference between manufacturing, engineering, and configurable BOMs and their nuances in the automotive industry. Finally, she has had a chance to touch on the importance of focus groups and how that drives the entire engineering and manufacturing process and tool selection and adoption for automotive companies. Let me introduce Melissa to you. For more than 27 years, Melissa has been dedicated to procurement and supply chain. Currently at IBM, her focus is to re-image digital transformation in a constantly changing global landscape so that organizations can remain relevant and competitive. Melissa was listed in the top 100 leaders and influencers to follow in 2021, top women in supply chain, and most recently, she was recognized internationally with the Global Leaders in Consulting Excellence in Influence Award for her accomplishments, including the automotive sector. In collaborating with executive leaders, Melissa redefines what success looks like today and helps execute a future vision for product lifecycle strategy that is both flexible to change and scalable over time. With that, let's get to the conversation. Hey Melissa, welcome to the show.
Glad to be here.
Of course, our pleasure, and we are super excited to dig deep into your background because you have tons and tons of background in the manufacturing as well as automotive. So we are super excited to learn about that. Just to kick things off, do you want to start with your personal story and your current focus?
Sure. I've been in procurement supply chain for over 27 years. And one of my areas of focus is within automotive. So for me, that means that I've been in automotive for probably at least 1/3 of my career. I started in automotive really, really early. And what got me more interested in automotive is I was asked by a major OEM to pull together a focus group and really think through what are the new product demands that a consumer is going to want in an automobile 5 years, 7 years out, which is really difficult to do because everyone's thinking about what they want in their automotive now.
Yeah.
But then you had to rethink through, how do I get these individuals, in this focus groups to think about what are some of the things they need, 5 years out. And the life cycle of automotive was whatever we came back with that focus group, they would actually pull in to their product life cycle. And those features would now be in that next series of cars that come out, in 5 years. And as I was working with the automotive company and pulling this information in, I got to see the whole life cycle of taking it from the concepts and the feedback from the consumers, pulling it into the product life cycle, looking at how the components are built and how they evolve into
Yeah.
these bill of materials and into the actual car and then into the assembly and into the finished product. And then finally it comes out the door. And I was hooked at that point. And so immediately after that, I spent a good majority of my early career focused in automotive.
Love it. And I think we are going to have so exciting time overall discussing the product life cycle of different players involved in the automotive space. But before we do that, we have one of the standard questions that we ask every single guest, Melissa, and that is going to be your perspective on business growth.
Okay. So if I think about business growth from an automotive perspective, what's driving automotive today is being successful and staying on track with consumer data. So for example, the number one problem that I've heard, in talking to folks in the automotive sector is that leaders are recognizing that they need a product centric data in order to support the development and staying competitive. And if you're a CFO in the automotive manufacturing sector, you're dealing with a lot of complexity. You're looking at everything from sourcing those parts and understanding the finances, the design, the technology, the marketing, the advertising, but you also have to recognize return on investment, capital investment, profitability, and cash flow. So there's a lot of things that the CFO has to be worried about. And one of those components that we can dive deeper into is understanding how the future of the automotive product lifecycle connects with what's been around for a while, your engineering BOMs, your manufacturing BOMs, your PLM systems, your ERP systems, and then pulling that and connecting it to strategic sourcing, getting the best price, pulling those prices back in, and being able to develop something that's not only effective and meets the standards of our consumers, but also with the right quality and the price point so that we can remain competitive.
Yeah, it's very interesting overall when I look at the automotive ecosystem, and I like to define it as ecosystem as opposed to industry, because there are a lot of different players in this space that are being touched by the consumer demand that you mentioned, right? Because if the consumer demand is going to change over the period of time, that actually drives how the cars are going to be built. That actually drives how the parts are going to be built for the car. So you have the whole ecosystem driven by the concepts, the overall product life cycle, as you mentioned. So to start with, let's start with the aligning our expectations overall with respect to the engineering BOMs versus the manufacturing BOM. And I know that these things get mixed a lot of times, even in the ERP community, even in the manufacturing community. So I want you to touch on these two aspects. But if you can also sort of provide your insight from the focus group's perspective, how the demand starts, how that translates into the engineering BOM, and then finally how that becomes a manufacturing BOM and maybe the finished good that actually gets shipped. So walk me through the entire life cycle while explaining the role of each of the components that are involved in that life cycle.
Right. I like the ecosystem perspective. I hope to use that. The challenge for automotive in particular, and earlier I mentioned that in my career, these focus groups were trying to outline what's going to happen in 5 years from now.
Yeah.
But as we've evolved into not only technology, but the more technology we use, the more information that our consumers have. And the more information they have, the more of a point of view of what they want or what they think they need from an automobile. So the challenge now is I can't have a 5-year cycle to go from what I think my consumer is going to need to then 5 years later, put something out there on the market and realize that my consumer's already changed. We see now consumer demand changing almost every 2 years. And then when you have these obstacles in that life cycle, such as COVID or challenges with the environment that are impacting, assembly and production in another country, all of those things impact the overall ability of that company to increase their revenue. So part of this process that's come into automotive is how do we get from concept or what we think the customer is going to want in 2-3 years from now and quickly get it through this cycle. And so that's where the engineering BOM comes in. So the engineering BOM is that first stage. It's the early stage. It defines, I've taken that feedback. They want more cup holders, or maybe something a little bit more relevant for women is we want places to store our purses. And there's a lot of space within the automotive vehicle that's being unused. So one of the things that's come out in recent studies, and you may have seen this already in some of the automotive vehicles, is taking some of that unused space and remolding those plastics to put a little place where you can put your purse.
Yeah.
So those concepts then come down to the engineering team who takes it, thinks about how to redraw that product, and then the engineering BOM or the bill of materials is the list of parts or the components that they need to make that product. Then as you go through the maturity of that process, you shift over into the manufacturing BOM. The manufacturing BOM is what you need as the final assembly, or what you need to purchase if you need to go out and purchase parts of what you need to purchase and create that final assembly. Then the next stage is the product structure. So the product structure is now I have my manufacturing bill of materials. How do I structure the product in parent-child relationships between my sub-assemblies and my assemblies? And then from there, you go out and you source.
Interesting perspective there when we look at things like consumer demand, and if that is actually going to drive the design, obviously there are going to be a lot of different moving parts overall in the manufacturing process, in the sourcing process, also in the engineering process. So one of the things that I notice in the field, especially when it comes to the definition of the BOM, because BOM is evolving, right? I mean, it's almost like representation of your manufacturing process. So when we look at BOM, and by the way, the name is also very misleading sometimes because BOM stands for bill of materials. But if you look at some of the older BOMs versus the newer BOMs, okay, when you compare the engineering versus the manufacturing BOMs, one of the differences as the systems matured, the capabilities become far tighter. Now the modern ERP system, the PLM system, they can manage far deeper data structures overall when it comes to the bill of materials, right? So initially, let's say if I look at the ERP systems that were, let's say, 20 years old, they were not as mature overall in their capabilities for bill of materials. And the only thing they could capture in the bill of material is going to be just the bill of materials. Okay, meaning they just had materials. They did not have the entire routing, the manufacturing process, and some of the manufacturing organizations still use those BOM. So the challenge that they are going to run into is for each of the steps that they might have in the manufacturing process. Now they might have the individual BOM for that step. So you don't really have the complete representation of your product. You don't have complete representation of the product structure. Even in case of engineering BOM, the challenge that a lot of organizations run into, and the difference that I have personally seen from the engineering versus your manufacturing BOM is that engineering is going to have far deeper components. For example, your geometry. For example, your temperature, the tolerance. I mean, a lot more things from the engineering perspective. But manufacturing BOM does not need to care for all of that. You are going to have far more revisions overall in your engineering process. Your manufacturing BOM does not need to care for that, right? So when you think about this whole product structure, okay, when you think about the engineering versus the manufacturing BOM, what would be your thoughts in terms of redefining or rethinking the BOMs, especially for the people who might be using these older systems where they might not have their manufacturing processes completely replicated in the BOM and the kind of challenges they are going to run into. So have you seen something similar in the legacy organizations where BOMs are not really representing the manufacturing process? And obviously you are going to run into a lot of different supply chain challenges, production challenges. So do you have any perspective on that by any chance?
Yeah, you actually hit it really well with the engineering BOM is the one that's supposed to change. It's the one that changes often. And by the time you get to the manufacturing bill of materials, that's pretty much your final list. It shouldn't be expected to change because you have the manufacturing BOM is supposed to be I have an idea of what I need to purchase or the components I need to make in order to make the final product. What I'm finding is that sometimes it swaps. Sometimes the engineering BOM is really specific to the CAD drawings and the specifications, and the manufacturing BOM is the one that keeps changing. And that may have been great, when we had our legacy systems and all we were doing was focusing on our PLM systems and our ERP systems. But the challenge now is that in order to get through our life cycle more quickly, we need to automate the full product life cycle, not just the bill of materials, not just the PLM systems, not just the integration to the ERP systems, but now integrating to taking data from the bill of materials, putting it into some sort of like sourcing, getting the prices, pulling those prices back out, putting the prices back into that manufacturing BOM so that we can now go out and purchase those materials, which effectively is what we need to build the product. And depending on where you are in your automotive cycle, tier 2, tier 1, or the OEM, that's the product that we need to build, which will then eventually be put in the car. So the challenge here is that, I was reading a couple of just some industry studies, with across Deloitte, IBM, KPMG, et cetera. And all of them, all of these studies pretty much are very similar, is that the results of these leaders, it goes back to these leaders need data in order to make these decisions. But they also recognize that these PLM systems are mandatory if they want to, these product lifecycle management systems, the PLM systems, these tools are critical in order to support the complexity of a modern product strategy. And that's really key because the PLM market has increased from $5 billion in 2017 to over $7.5 billion predicted for 2022. So there's a lot of companies out there, these tier 1, tier 2 companies that didn't even have an automated PLM system. And we're seeing a huge increase in the market going out and buying these systems. And as a result of that, as a result of applying that technology, these legacy processes are having to be completely redefined. And it's going back now, circling back to your comment, the engineering BOM is the one that's supposed to change. It's the one that's got the CAD drawings, the specifications. The manufacturing BOM is the one that's supposed to stay pretty relatively static. And we use that to go out and purchase our products and materials. Unfortunately, that's not the case every time I visit somebody.
And you are absolutely right, to be honest. And the reason why you are seeing these change orders, typically, in the ideal scenario, let's say if you have the perfect manufacturing process in which we have our PLM system, we have our engineering process, and our engineers are completely versed in the manufacturing process, how whatever they are designing from the engineering perspective, when that flows down to the manufacturing pipeline, it's going to work as they had estimated. It's going to work as they had designed. But in the real life scenario, this is very rare. Because number one, the engineers don't spend as much time on the production floor. They don't really understand how these machines operate. So they are designing more of this in theory that, whatever I am actually hypothesizing from the concept perspective, it's actually going to work in the real world. So the reason why you see all of these change orders is because when you have the real world situation, things are not going to work as you had planned. So that's why you see a lot more change orders. So obviously, PLM plays a very important role because when you are collaborating, let's say, with your suppliers, because you have to do the estimation, you still have to do a little bit of R&D. Maybe you need to do some sort of proof of concept in the design phase, and in that as well, you need to collaborate with your suppliers. You need to find out the pricing. You need to design your BOM so that the design is actually going to be feasible. So I completely agree with your assessment there that PLM has a place depending upon how complex your manufacturing is overall, depending upon how many revisions you are going to get, depending upon how sophisticated your manufacturing processes are.
And you can't see me smiling, but you said something that caused me to just grin from ear to ear. A minute ago, you said something that really just resonates a lot with me. In 2019, I was actually working for an automotive company outside of the US, a global, tier 2 company. And what was interesting is I pulled in a huge workshop to talk about the process, going from the bill of materials to the ERP, the PLM, et cetera. And I pulled in procurement people, and I pulled
Yep.
in the engineering people, and I pulled in the ERP people, and I pulled the PLM people, and I had 40 people in a room. And and as I'm talking through the future state process, suddenly somebody from the engineering team, steps up and says, "But wait a second, you're telling us that if we want to automate this process, we can only pick one bill of material to go into the system." And I said, "Yes, that's right. Well, which one are we using?" And
Yep.
the question just completely took me by surprise. So I said, "Okay, well, let's set the agenda aside and let's dive deeper into this question. First of all, why are we asking the question? And what is it about your process that you think that this isn't going to work?" We literally had a 2.5 hour conversation between engineering, ERP, technology, and purchasing just on the concepts and the differentiation between an engineering bomb and a manufacturing bomb and why the manufacturing bomb is not supposed to change. And so you mentioned something about pulling in procurement and the engineering team together, and I just had to grin because that actually just recently happened just a couple years ago.
You are absolutely right, and yeah, and that's how it is supposed to be. But manufacturing bombs do change for very small revisions, in which case the engineering does not need to be involved. Your product does not need to be changed. So, for example,
Hmm.
let's say if you have a manufacturing floor situation and you are on the manufacturing floor where you, let's say, planned for a specific item and now you are short of that item, and now you are sort of stuck on the machine, but you need to make sure that you are moving forward with that, because you need to sort of move ahead because that's already on the production floor. So if you, let's say, need to replace a specific item, now that could be defined inside the BOM, which are going to
Hmm.
be the specifications in terms of what materials you might be able to use as the substitute in those BOMs. You could do that, or you could simply make a decision right there and
Hmm.
then figure out what needs to happen, because it's almost like when you are in the production floor, you need to keep moving. If you don't keep moving, you block everybody else, and that's very expensive because your machines are going to run idle, and then your people are probably going to be waiting. You are going to be blocking everybody. You need to make quick decisions and you need to move fast. So in those cases, the definition or the BOM or the revisions might change on the manufacturing floor, but otherwise,
Hmm.
engineering should take care of this as part of the product definition. So let's go back to the product structure that we had, identified to begin with. Now,
Hmm.
when we look at different tiers of the automotive market, right? So everything is driven from these focus groups, from the consumer demand. A car uses, let's say, what, 30,000 parts? I don't know. And each of these parts are going to be supplied by one of those tier one and tier two manufacturers, right? And they need to have some sort of visibility in terms of how these parts are going to be used overall in the manufacturing process, for them to be able to design in the right manner, so that when this is all going to be assembled, it's going to work together. Right? So when we
Hmm.
think about this product structure, and when we think about the relationship between these sub assemblies, and especially when multiple geographies may be involved, what are some of the best practices that you have seen in the designing the data relationship across the companies, in choosing the vendors, and also inside your own entities as well, if you may have, let's say, multiple sites, one in the US, one is in Mexico. So what are some of the best practices that you have seen, and if you have any stories, you might be able to narrate that.
You said something that I thought was really interesting. It was,
Okay.
yeah. So before the whole question around the data management of the product structure, in your comments, so you said something really good. It was around the data sharing
Yeah.
of these manufacturing bombs. And
Yeah.
you even commented that the manufacturing bomb could slightly change, which is possible.
Yeah.
But then as you're working with these suppliers globally, how do you ensure that they're getting the updated information? And that's always been a challenge. You
Yeah.
know, that's always been a challenge. And the way the market is trying to solve that is, as we again go, recapping the process, the bill of materials, the PLM systems, integrating with an ERP system. What's happening in the market in the last 5 years is applying another set of tools that can take that manufacturing bomb, put it into some type of product life cycle sourcing management, tool, and be
Yep.
able to communicate with suppliers. So then from that perspective, if the manufacturing bill of materials does slightly change, these are sometimes huge CAD drawings. I mean, some of these CAD drawings, just one drawing can be over 20 meg. Our systems right now aren't able to compensate for that. And if they could, upload new materials and information to the suppliers, that's a lot of manual activity that you're asking your end user to focus on. So, for example, if I'm in the middle of a sourcing process where I'm sourcing out some of these assemblies, the product structures around the manufacturing BOM, the assemblies, the sub-assemblies, and even some of the components, and the manufacturing BOM changes, twice within that 3-week period, I
Yeah.
somehow need to get that information to the supplier. That piece is still not quite polished yet. So some of the workarounds that we have in the industry is we go back and revisit the PLM system. And what we've recognized is that a lot of these PLM systems have a way that they can open the door to the PLM system to all of these suppliers and allow the supplier to come in and view the specs. But the challenge is that as we're, working with each of these clients, we're finding that a lot of times they don't know a lot about their own PLM systems. They've been around for a long time. They didn't realize that these upgrades and new features had been applied. And so they're trying to go and really create this really complex manual process when a lot of times it's just go back and look at your PLM system because there is a feature out there that says you can open the door to your CAD drawings. And while, yes, they're over here in this one product looking at the specifications and feeding you back the total cost, they could also come back into your PLM system and see what the new CAD drawings look like, see what the definitions or the specification changes, and then go back and reapply them. It's not a perfect system yet, but that's something that I absolutely agree with. It's still a bit of a challenge.
Okay, amazing. So since you had some interesting stories there when you are talking to these engineering guys and the manufacturing guys, I'm pretty sure you are going to have some more stories related to the problems that you have discovered in engineering versus the manufacturing BOM. Do you have any more stories that you might be able to share there?
Yeah, the integration piece. So again, working with some automotive companies the last couple of years, it's a bit of a mind shift to go from these systems that you've been working in for the last 20 years and suddenly, shifting to cloud-based systems, adding these cloud-based systems on top of these ERP systems and sometimes these PLM systems. And one of the other topics that comes up a lot is how is the data flowing through in a way that's going to make sense. So, for example, I still find today that PLM systems aren't integrated into the ERP. Okay, great. I can help you with the future state process and I can help you reduce your overall cycle time in the entire product lifecycle management. But if the PLM system isn't integrated in anything, then that makes this whole process really difficult. So the challenge here is that a lot of these companies, they're ready to move forward and make changes, and they have consultants and experts come out and work with them, and then everything gets put on a pause because now suddenly the data that's in their PLM system is not integrated to anything. It's just sitting out there as a standalone. So I would say that's another huge challenge that we tend to face is I think there's a checklist that we could probably come up with by the end of this discussion. I think we're starting to develop a checklist that we can leave behind and say, before you even start a project, here are some things you guys need to really think about and discuss internally so that you are setting yourself up for success.
Okay, amazing. And when it comes to defining these BOMs and the product structure for, let's say, automotive industry, and you work across different industries, right?
Mm-hmm.
So what are some of the nuances that you have seen, especially when it comes to your engineering and the manufacturing BOMs? Are the BOMs different in the automotive industry? If they are different, how different are they, and what are going to be the implications of these differences? So, can you talk about the specifics of the automotive industry comparing with the other industries that you have seen, especially around product definition?
Yeah, there's just slight nuances. I've seen some companies use 3 different types of bill of materials instead of 2. The most common 2 are the engineering BOM and the manufacturing BOM. But I've also in, say, telecom and other types of, specifically within the telecommunications industry, I'll see something called a configurable BOM, a C-BOM,
Yeah.
which is very different, not something you typically see in automotive or, new product innovation. But the CBOM is, let me think of a good way to, do you have a definition of it?
Yeah.
Like worded,
So
yeah.
typically the configurable BOM is going to be, let's say, if you have a process where either your salespeople are going to be utilizing the configurable process. For example, let's say if you have a complex product where something like the forklift in the warehouse, or for example, let's say if you have a door that you are configuring. So these configurable BOMs are going to be driven by the consumer demand, where either the consumers need to go to your website and select many different features before you can select a product that you really want. And your
Hmm.
manufacturing process is actually going to be driven by these configurations that the consumers are either defining, or salespeople are helping the consumers to define these products. So the reason why you see this in case of telecom is because they might be selecting, let's say, one of the telecom equipments, right? And in case of telecom equipment, they might have many different the voltage and current, and I don't know what all is going to be relevant in case of your
Yeah.
telecom
Yeah.
product, right? But all
Yeah.
of those options are going to be required to incorporate in your BOM. So you have this generalized template in the backend that you utilize to be able to configure many different options that you can pick and choose. So you have the generalized template as opposed to just having a fixed BOM in case of manufacturing, but they are configurable. So you can sort of the branch off these different configurable BOMs and you can send to your production process depending upon what the consumers are looking for. So this typically
Right.
helps in driving the overall sales process, expediting the sales process. You don't have to
Hmm.
have so many different product definitions. So that's my experience. Do you have similar experience there?
Well, what I've found, and kind of echoing what you've said, is that when you do have a configurable BOM, you absolutely have to have a multi-level BOM.
Yeah.
And I don't typically find a lot of multi-level BOMs in automotive. So just to step back, a typical bill of materials manufacturing BOM is going to have a parent-child hierarchy. You're going to have, here's my assembly, and then maybe underneath it, a list of sub-assemblies with a list of product and components that make up that sub-assembly. But
Yeah.
with a multi-level BOM, it's structured with multiple layers child. So I may have a mix of finished sub-assemblies, which then underneath that could have two more sub-assemblies, which then finally have the materials and parts underneath it. So what I say the biggest change, the biggest differences I probably see is I'm not seeing right now a lot of overly complex multi-level bill of materials in automotive, but in other sectors like telecom, and that's a good one to probably highlight, is in sectors like telecom, we do have these third options, which is the configurable bill of materials, but it's completely dependent on utilizing that multi-level BOM process.
Interesting. So can you break it down a bit further, what you mean by multi-level BOM? And I don't know if you're going to have an example of a part that you are building in case of automotive. I'm not even sure if this is really related to the OEM or you are talking about a supplier. So can you describe the manufacturing situation and where you are not seeing multi-level BOMs?
I don't have a specific example off the top of my head, but the reason why a lot of companies weren't using multi-level BOMs is because a lot of the bill of materials are still in spreadsheets. So when we talk about the process and me, walking in the door and I'm looking at their current state process, they're using spreadsheets to really keep track of their BOMs. So when the manufacturing BOM comes in, they put it all on a spreadsheet. They then work with the different product owners and say, hey, this part of the subassembly, you need to go out and work with your suppliers and find the best price and quality. And then over here in the other, part of the manufacturing BOM, these subassemblies, you need to, assign those to a different product owner to go out and source, et cetera. But it's really difficult to manage multi-level BOMs within a spreadsheet. So that's why when I typically walk in the door and I'm seeing companies that have these legacy systems, they're also still using Excel spreadsheets to manage these bill of materials. Now, the multi-level BOM, if used in the right way, can absolutely reduce risk. So a multi-level BOM can reduce risk when you have products that use parts with really long lead times. That's where that multi-level BOM comes into play, and which is why I typically don't see it with automotive. When you're dealing with an automotive company, they're looking at parts that need to come in with a fairly short lead time, not I need a spring that's going to take 6 months for me to get the spring, which then I build into the brake assembly, which then I turn around and sell to my OEM. Whereas the multi-level BOM is parts with either really high inventory cost, where your vendors, your single sourcing vendors, there's nobody else out there in the market that can make it, or very long lead times where you're working with a supplier that will typically have to create that part or that component from scratch. So that would be another reason why I don't typically see multi-level BOMs in, say, automotive at the moment.
Okay, amazing. Thank you so much, Melissa, for that. So that's it for today. Do you have any last minute closing thoughts by any chance?
Yeah, I think what's evolved over this conversation is that we've actually highlighted almost a checklist that if you're listening, things that you can take back and think through before you start, going into this larger project. And as you're looking at these systems, as you're starting to move things out of Excel and into these PLM tools and these product lifecycle management tools, really before you go out there and buy the product, or before you're, assessing multiple products, talk to somebody that knows the industry. Because the number one challenge I see is that if the automotive client is out there looking at different products and trying to understand how that product's going to layer in on top of what they already have, the terminology between this company, their product, and the terminology with that company is like a whole nother language. And so really, before you make the decision, I always just recommend having somebody, even if it's a friend, that you can reach out to and ask them questions, not because you're going to make the wrong decision, but because we want to make sure that you're asking the right questions. And the more questions you can ask and then understand how they're answering the question, the better your overall journey is going to be. I think the other question, the other thing that we've talked about is really thinking through in your current state process, are you really using an engineering BOM and a manufacturing BOM kind of how the industry has defined it? And that's important because as you go and add all these other products and cloud-based services on top of your current process, they're using very standard, very strict definitions. So if in your legacy system, in the way you've done your legacy processes, if you've been very fluid with how you've defined these, for example, allowing your manufacturing BOM to change just as much as your engineering BOM, then it's going to take some time to think through that before you can start automating it. Lastly, I think the one thing that we mentioned is go back to your PLM system and check on features that are already there that you may not be aware of. And you're going to find that there may be some things that you've struggled with today. But if you look at what systems you already have, a lot of these systems have been pushing out features and functionalities that it requires you to go back and say, yes, I want to turn those on. So that would be, I think, the third thing that I think we've discussed today.
Okay, amazing. And my personal takeaway from the conversation is going to be the automotive ecosystem is very unique because you have nuances of consumers driving the demand, and then finally you have a very complex engineering and the manufacturing process. So obviously, because of the process complexity, you have a lot of moving parts that you need to think about before you create your product structure or you create your engineering and manufacturing BOMs. On that note, I would like to thank you for your time, Melissa. This has been an insightful conversation.
No, thank you. I really appreciate it. We'll have to do this again sometime.
I cannot thank our guests enough for coming on the show, for sharing their knowledge and journey. I always pick up learnings from our guests, and hopefully you learned something new today. If you want to learn more about Melissa, connect with her directly on LinkedIn. Her LinkedIn handle is m-drew. It's m-drew. She is always open to networking and willing to share lessons learned. Links and more information will also be available in the show notes. If anything in this podcast resonated with you and your business, you might want to check other related episodes, including the interview with Jennifer Heron, who discusses how 3D CAD models can improve cross-functional collaboration and design from consumers' perspective. Also, the interview with Andrew Hood, who discusses why classifying and promoting the reuse of parts is vital to save costs. Also, don't forget to subscribe and spread the word among folks with similar backgrounds. If you have any questions or comments about the show, please review and rate us on your favorite podcasting platform or DM me on any social channels. I'll try my best to respond personally and make sure you get help. Thank you, and I hope to catch you on the next episode of the WBS Podcast.
Thank you for listening to another episode of the WBS Podcast. Be sure to subscribe on your favorite podcasting platform so you never miss an episode. For more information on growth strategies for SMBs using ERP and digital transformation, check out our community at WBS.rocks. We'll see you next time.